Okay, so today we are going to just end up this chapter and just solve the questions related to the topic of pressure because we already discussed that there is no topic related to the hydraulic system and there is no concept related to the manometer. We only need to discuss about the barometer reference to the height. So the next topic that we are going to discuss is basically related to the pressure in gases that are related to the gas laws also, because that is also included in your thermal physics section. And the next one is, and the that concept is also included in this section. So that is very basic concept because that topic is mostly asked in the concept of the pressure. Like in alternative air they mostly used to ask about that question. So that is the concept related to the gas laws. So the first law that we need to discuss is related to the Boyle's law. So in the previous class, we also discussed just the reference from the Boyle's law, that just like that if we take the common example of the breathing. So during the breathing, what happens actually, our lungs sometimes contracts and sometimes when lungs actually expand, so we are taking air inside. So actually that decrease the inside pressure, right? So when the pressure inside the lungs decrease, so the volume automatically increase, right? Because air molecules now filled in the lungs, so that's why the volume of the lungs increase, right? And let's suppose if we want to increase the pressure, so we want to just apply the force on it, and when we apply force on the lungs, so the volume will decrease. So both work like inversely, right? If we increase the pressure, so volume will decrease, and if we decrease the pressure, so volume will increase, right? So that is the Boyle's law. And one more important thing in the Boyle's law, that temperature must be constant. There will be no change in the temperature. Okay, because if we change the temperature, so they will definitely increase the kinetic energy. So that is the basic concept. So at constant temperature, so basically at constant temperature, the pressure of gas is inversely to the volume of the. So basically, this is the concept of the Boyle's law. This is the statement of Boyle's law, that at constant pressure, both quantities are inversely proportional. P
So
is
is
in.
there any formula which
Yes,
relates pressure and volume?
yes. And formula is very simple, and you find many questions in the past papers that are related to this formula. Even the formula is very simple, and the concept like the repeated concept, because you know that this is a law and it remains same every time, right? It will never change because this is a proper law. So you find the question, we also when we try to solve the questions today, so you find that for 2 or 3 marks they used to ask about the theoretical question related to this concept. So basically P is inversely proportional to V. We are not taking the value of T because T is actually constant. Or if we take the value of T constant, so this will be equal to T over V, and T will be equals to,
Pressure times volume.
yes, pressure times volume. Now let's suppose if we consider two situations, the initial state and the final state. So let's suppose at initial state our pressure and volume is equals to P1 and V1, and at final state we can say that pressure will be P2 and V2, right? Because we know temperature remains constant. So if we allow to compare this equation, the initial stage and the final stage of the gas, so we can say that the temperature in both condition remains same. So in both state temperature remains constant. So that's why we are using only T. We are not writing 1 and 2 because 1 and 2 actually gives you the concept of the change in temperature. So P1 V1 will be equal to P2 V2, right? And this is the most important equation for our numerical questions related to this Boyle's law in the chapter of pressure. So this is the concept, right? So this is the first law, and this law is actually related to the pressure. So that's why we need to study this law before the thermal section, because it also includes the pressure and the volume concept, right? And the next thing is second law is related to the Charles law. Actually, they never ask about with the reference of the name of the law that define Boyle's law, define Charles law. They just ask in the sense that if we increase the pressure, so what will be the change in the volume, explained in the terms of the molecules. So they will ask like this, right? They never give the reference of the Boyle's law and the Charles law. So basically, if we talk about the Charles law, so Charles law actually gives you the concept of uh, pressure and temperature. Now volume remains constant. So if the volume kept constant, pressure is directly proportional to the temperature. So this is the law. Now we need to use this law to explain the molecular structure, that what will be the change in the molecules when the temperature of the gas molecules changes, right? And if we want to write the equation, so equation will be the same, just like P is directly proportional to T and volume is constant. So P is equals to Vt, right? And again, if we want to use the initial stage and the final state, so that will be equals to P1 over T1 is equals to P2 over T2. Now the question is that why the pressure will increase when if we increase the temperature, so why the pressure of the gas molecules increase? So this is the main question.
Wait, can you repeat?
Basically, in this, we need to discuss that we know that pressure is directly proportional to the temperature, but in question they used to ask with the reference of the molecules. That what will be the
Kinetic.
effect on the molecules? Yes, one
When the
concept
temperature
is that.
increases, they gain kinetic energy. So when the volume is limited, they exert more pressure.
Yes. So basically it works with the concept of the molecules, right? So basically this is a natural fact. If you provide something energy, just like if we connect a battery with the lamp, so you know that that lamp will be light up because you know charges uh, is going to be supplied from the battery to that lamp. Okay, so basically when we provide
Wait, so I have a question.
Hmm?
Can you explain why it's P1 over T1 again?
Because it will be like, we just consider this equation. P over T is equals to V, right? Because we know volume is constant. So this is initial state
Okay.
and this is final state. And if we compare the equation, so both side we
Wait,
are
sir, isn't temperature over pressure equal to volume?
temperature over pressure.
Yeah, if we use the triangle method,
You
like
can also write that. So that can also be possible. Only your positions will be shuffled.
like that.
Yes, you can also write that. Let's suppose if we consider this equation, right? For the time being, we are writing P1 over T1 is equals to P2 over T2, right? If we just cross multiply the thing, so your equation will be T2 over P2 is equals to T1 over P1, or you can also write that one T1 over P1 is equals to it. That remains the same. If we cross
So
multiply,
T2 over P2 is equal to T1 over P1.
it will be like this. So T2 will be shifted on the left hand side and
So
P2 will
T2
be
over.
here.
Okay, okay,
So again, you got the same concept, right?
okay.
Because this is the mathematical equation and both are equal means you can shuffle in any form that you want.
Oh, wait, sorry. So it's based on this formula, right? Because now we have new, what do you
Yeah,
call a new condition? Okay, okay, sorry, sorry.
because in previous we are taking temperature constant and in this we are taking volume constant. Okay. So
Yeah, yes, yeah, understood, sorry.
yes, so basically they usually ask the question like this. They usually ask the question in terms of molecule, explain, or explain in terms of molecule how this will affect that. Okay, so basically they ask question with respect to in terms of molecules. So basically in terms of molecules, we can say that, let's suppose if we consider the example of Charles law, right? So if we take the reference of Charles law, let's suppose we apply temperature on any different, we can say that on any container containing a gas in it. So let's suppose if we consider any container, if we apply thermal energy, so we supply heat or thermal energy because that will increase the temperature of the gas. And we know that we need to take the volume constant. So we just take a lid over here and you can see if we take the lid and this lid is completely fixed, volume of the container and the volume for the gas will not change, right? So that is the condition. And this container is completely filled with the gas. And we know that when we supply heat energy or the thermal energy, so the molecules of the gas gain that energy, right? And
Kinetic energy.
yes, and we know that gas molecules are free to move, right? So when they gain energy, so they try to vibrate, we can say that, or their amplitude of vibration or their motion as compared to the previous state will automatically increase, right? But the
Yeah,
problem is that the volume is fixed, right? Just like take the example of pressure cooker, we know that pressure cooker is also tightly packed, right? It means the volume is fixed. There is only one nozzle, right, that actually move in upward direction when pressure is very much greater, right? So to release that pressure, that nozzle comes up and the gas or the steam slightly starts to come out from the pressure cooker, right? So the basic term is the kinetic energy of the molecule increase, and their motion, their vibration, their amplitude of oscillation, you can write anything, so that will increase, and they try to push that lid in upward direction, or they try to apply more force or the greater force, or you can also use the word of momentum, right? Because we studied about all these terms now, right? Because molecules have
Yeah.
and when they move with some speed and collide with the container or the lid or the walls of the container, so you can also use the term of momentum. So the key terms are the kinetic energy, momentum, force applied by the molecules on the wall or on the container. So these quantities will increase, and when you know that molecules are not able to move in any other direction, so they are completely packed in a fixed situation, so that will increase the pressure on the container and pressure on the lid, right? Okay, so this is the concept. So basically they ask the question in the sense that explain in the terms of molecule. So that is the reference that how we explain the concept in terms of molecule. We also discuss this concept in the chapter of or in the section of thermal physics, but mostly the questions are asked in this section. So that's why this law is very much simple and it is not very difficult, right? So let's suppose if we consider one question, because this is the last thing that we need to discuss in this chapter, right? Because you know that in atmospheric pressure they only ask about that height. Manometer is already excluded. So whenever you find the concept of manometer, so just skip that question. So manometer is completely excluded. And the next topic is hydraulic lift and brake. This topic is also excluded because these are the major topics from previously from this change in the syllabus. So that's why you
Sir,
find
what is
many
this
questions.
lesson about? Is it pressure?
Yes, it is related to pressure.
Okay. I didn't come on time, so can you
Yes.
summarize it for me quick?
Actually, this is a detailed one. You can just take the reference from this. Just take the reference from these gas law, right?
Okay, let me
Because you
write
have,
it down. Let me write it down.
or you just take the screenshot and just take in front of you, and try to answer the question, right? Because our main concern is to write the answer, that how to write the answer related to this question. Did you take the screenshot or you writing? Okay, let me know
Sir,
if
I took a screenshot. I took
okay.
a screenshot.
Okay, that's good. So now you can see that in this question, question number 1, there is a question related to that same gas piston. Piston mean in simple words lid, because in scientific terms we mostly use the word piston as in the place of the lid. So basically, a question is a liquid occupies a much smaller volume than a gas, which has the same number of molecules. Explain why there is this difference. So basically, this is related to the general state of matter. So for the time being, you may just skip this question, right? But basically, this is very general question, and you all know about this, that why volume of the liquid occupies less space. Anyone wants to answer?
Sure. This will give me 1 mark, that's for sure. So the reason a liquid occupies a much smaller volume than a gas for the same number of molecules is because in a gas, the forces of attraction are much weaker
Yes.
compared to liquids, and so gases are able to move freely, while
Mhm.
liquids are just able to slide over each other,
Okay.
which
So
is why gases are able to occupy much more volume.
yes. So basically, this is very journal concept. We are studying this states of matter from class 6, 7 like this. So we already know about this. We already studied that liquids, solid have fixed shape, definite volume. Liquid does not have any fixed shape, but it has some sort of volume because when we contain in any container, so then it contains the same volume. So one concept is related to the weak molecular forces between the gas molecules, and the second one is that gas molecules are free to move as compared to the liquid molecules, right? So that's why gas molecules occupy more space. Their force of attraction or their intermolecular forces are also very weak. So in this sense, we can say that the liquid occupies much smaller volume as compared to the gas having the same number of molecules, right? So one concept is related to intermolecular forces. And don't get confused in this question because our next section is completely related to this one. So you will
Oh
get
wait, sir, we
the concept.
sir, we can't say forces of attraction.
You can also say that.
Okay, okay.
So, and the second thing is free to move. Gas molecules are free to move as compared to liquid. So this is for gas. This part is related to your pressure section. The volume of the gas changes from V1 to V2 as the piston moves into the cylinder. This increases the pressure from P1 to P2. The temperature remains the same. State the formula that relate V1, V2, P1, and P2. So you just need to write the formula that gives the relation between all these terms. So that is the,
P1 V1 is equal to P2 V2, I think.
yes, that is the formula.
Okay.
So you can see that this is very simple concept, and still they are asking that one. And you find this concept repeatedly in many questions, almost like in each year. And now from the new syllabus changes, we already have very short in topic in chapter pressure, so now they also ask in very much detail about this concept. Okay, next question or the part of the question is the initial pressure of the gas is given over here, and the initial volume is 100 centimeter cube. The cross sectional area of the piston is 5 centimeter square. The piston is pushed in a distance of 8 centimeters. So these are the values, and we need to calculate the final pressure. So basically, this is our initial pressure P1, okay, and this is our initial volume V1, and then the cross-sectional area of the piston is this, and we are having the piston is pushed in a distance of 8 centimeter, and we need to find out the final pressure. So all of you clearly knows that we need to
Oh
use,
wait, I think I get what's happening here.
yes,
So a volume is length times width times height. So
yes,
let's just say we have length and width, and then this distance is height. We multiply it with with the area, and then we get the new volume, which is V2, and then we can use the formula to find pressure, right?
yes, simple. Because you already studied about the dimension in pressure chapter, so now it is not much very difficult for the reference because this is first question, so I'm writing in detail. So this is initial pressure, this is initial volume. Next, this pressure is unknown. The final volume is A multiplied by H or D, anything. Because we know that in volume there are three lengths combined. So we just need to multiply 5 by 8. So 5 is
Sir, the answer is 300,000 pascals.
okay. So this is your new volume, right? And you can easily compare that. They mention the initial pressure of and its volume is
What did he say the answer was?
30,000,
300,000.
300,000.
Yeah. Yes.
You will get answer 300,000. Okay, try to do one thing because you can see that question is for 3 mark, right? So you got answer 300,000, right? So try to write in your answer like this type of answer when we are having only zeros over there to write in
Standard
scientific.
form.
Yes.
Okay, so 3 times 10 to the power of 5 pascals. Okay.
Yes. Okay, so basically we just solve this question and the final part is explain using ideas about molecule why the pressure of the gas changes.
For 1 mark. So what concept do we use here? Temperature, right?
Yes, temperature is constant. In
Yeah,
part,
temperature is like constant, no?
yes, temperature is constant. So we
Oh,
just
okay.
need to explain Charles' law in simple words, right? Because they never
Yeah,
mention
yeah.
about the name of the law.
So the
But
temperature is constant, an increase in
The pressure is
volume results
direct
in
to
an
the
increase in
temperature.
pressure.
yes, so you can just
They both
simply
have the same
write
answer.
that because from calculation we are also getting the concept that if we decrease the volume because our volume is decreased like the V2 is less than V1, so our pressure is greater than P1, right? So both are inversely. So you can also get the calculation concept over here, right? So we can say that pressure of the gas molecules are inversely proportional.
Wait, inversely? Or
Yes,
directly?
with volume.
But in this
For
formula, they're directly related.
Boyle's law. We are working for the Boyle's law.
Oh,
P1
it's
we
constant temperature. Okay, sorry, my bad, my bad.
this is the one way to write the answer because question is of for only 1 mark, and the second method is to write with the reference of the values that is all values mentioned in part 2 of the question, right? You can just take the reference that initially we are having pressure and the initial volume, and when we decrease the volume so our final value of pressure increases, so we can say that pressure and volume are both inversely proportional, right? But question is for only 1 mark, so we don't need to extend the question in detail, right? Okay, now you can see that this question is not much very difficult, easy 7 marks, I think. Yes, these are the question manometer. Just skip this question
All right.
uh, because some
Pressure.
parts are included, but we are going to solve this manometer section because it there will be some confusion that either this topic is included or not. So that's why we just get question related to manometer. You can see that again, question number 3. They are again
Wait, sir.
asking the
I'll try
same
and
question.
answer in the chat. 1 second.
Yes. So you may try to answer this one also because this is also the same concept. Okay, if someone want to answer, so you may answer because One of you
Yeah,
type
sure.
in the chat. So I got
Uh,
air contains gas molecule which have weak forces of attraction and so are free to move and collide with the inside of the bag and thus exert a pressure. Okay, that is fine. So basically
is
again
that
the
too
same
much?
concept, yes, because there are two concepts. One is again the same concept, intermolecular forces or force of attraction, and the second one is the distance between the molecules, or we can say that the molecules are free to move, right? So basically,
Yeah.
in this bag we are having this volume, right?
So can you also say that gas takes the shape of its container?
Yes, you can also say that.
Yeah. Okay.
So basically, your volume is fixed, and they are asking explain how the molecule of the air in the bag exert a pressure on the inside of the bag, right? So basically, you can also write with the reference of kinetic energy of the molecule, right? Gas molecules are free to move. Less or weak intermolecular forces. So molecules collide with the walls or surface of the bag, increasing the pressure inside the bag, right? And you can phrase according to your choice, right? It is not compulsory to just copy paste the same thing because you already got the concept. So now it is not much very difficult for you, right? And again, we are having same concept. When the bag is closed, the pressure of the air inside the aircraft is 80 kilopascal. This K means kilo. It means 10 to the power positive 3. And the bag contains 500 centimeter cube of air. So this is initial volume, right? And when the aircraft is on the ground, when the pressure of the air inside the aircraft is 100 kilopascal, now you can see that pressure is actually increased. So this is P2. Now again, they are asking the same thing, V2. Okay. So you can see that again, they are asking the same question with different situation only. And we can say that, okay, one more important thing, when you observe that both pressure has kilopascal unit with that, so you don't need to write like 80,000 or 100,000, right? Because you know that kilo and kilo will automatically cancel out on both sides, right? So we need to find actually V2. So P1, V1, P2. So you can just simply write the values like this. P1 is 80 kilo multiply by V1. So this K will automatically cancel out, right? So 400 will be the volume, right?
Yeah.
So this is the answer, right? Now you can see that again they are asking the same thing for the 4 mark. And state two assumptions that you made in your calculation in part B, question B, part 1. So you need to write two assumptions.
The temperature being constant.
Temperature being constant, good. And the second one is
Uh,
the statement of the law.
Pressure is directly proportional to volume.
Pressure is directly or inversely?
Inversely, sorry, I'm getting confused. Yeah, inversely.
That's an assumption.
Yes, because that is law, and in the law, it is the assumption that your temperature is constant, right? And the second thing we consider that pressure is inversely proportional, right? Because we are not defining law, we are just applying that law on the question, right? So they indirectly asking about the concept that what is the law actually you are using in that question, right? Their way of asking is different, right? But we know this is the assumption that we apply on it, because there are four different values, so we can solve it in any way, right? But we only consider this situation that we take temperature constant, and when temperature is constant, so pressure is inversely proportional to volume, because this time in question it is not mentioned that temperature is constant. So basically we are working on assumption, right? Because if temperature constant, so
Yeah,
then pressure is inversely proportional to volume. Again, same copy paste question for 6 mark, right?
yeah,
Okay, question number 4. You remember this concept, right? We were talking with the reference of pressure in liquid. So basically we are having a tank filled with oil, and there is a crack in the tank at the depth of 3.3 meter. So this is the depth. So let's see first they what are asking about. So the value of G is given. Next, density is given. The depth of the crack is given. They are asking about the pressure. So what will be the formula to calculate pressure?
okay. Pressure is equal to density times gravitational field strength times height.
So don't get confused between two formula. You know that we are working with liquid. So simply apply pressure in liquid formula rho GH.
The final answer is 3,000, no, 31,020.
31,020 pascals.
Okay. And again, try to write in scientific, just round off the value. Don't worry about that. If you are writing in simple form, so that will be, right, 31,000 pascals, or you can also write it as,
3.1.
okay. So just try to round up the values.
The standard form is preferred.
uh yes, if you are going to, that is the exponent, the scientific notation, right? So if you are going to write in the scientific, so that will be more preferred, because we know when we round off the value, so when there are multiple zeros, so that's why we use the scientific notation. Okay. Next is explain why the atmospheric pressure does not affect the rate at which the oil is pushed out through the crack. Last time we discussed with the reference that atmospheric pressure continuously apply on each and every body. So when we are talking about the pressure in liquid, so this tank is open from the top, right? So you can see that it is open from the top, so pressure can be easily apply on the liquid uh, from the upside. Okay. So they are asking, explain why the atmospheric pressure does not affect the rate at which the oil is pushed out through the crack. So what is the reason?
Uh, I'm
Okay.
not sure about this.
Okay. Very
It,
sim.
is
Yes.
it because it's the same everywhere, so it
Yes.
doesn't affect the
Yes.
whole thing?
Simple concept, because we are not talking about any change in atmosphere, right? So we consider that the
It
atmospheric pressure remains constant, right?
Doesn't atmospheric pressure change with height? So
Actually,
like it would be like a little bit less here compared to here.
no,
It will
actually,
be a little bit more.
it will happen like this when we take this experiment at some certain height, right? We are at sea level, so at certain level in the atmosphere, the pressure remains same, right? It not happens like this that on the sea level, it will change after very short distance, right? So last time we also discussed if we consider that someone is living at some height or some at mountainous area, so then we compare the difference in the pressure, right? But if we consider at sea level, so sea level, it means the normal atmosphere in which we are living. Okay. So that's why we consider that atmospheric pressure remains constant throughout the experiment, right?
Okay.
If they mention a very clear difference in the height, like we are moving 1,000 meters away from the ground, so then it will affect, right? But in this condition, we know 3.3 meter is a very short distance, so that will not affect like a very much change or a very big change in the whole process, right? So you can explain in term of the constant term. You this by your own. It's up to you. And next thing is, as time passes, the point where the oil hits the floor moves away from P and towards the tank. It means that now we are receiving the oil drops over here. So they are saying that now P is moved towards the left, and when they are moving towards the left, so it moves close to the tank, right?
Yes.
Now the question is, explain why this happens.
The when like the oil
The
is
amount of water decreases. So like
oil,
Hmm.
yeah, the amount of oil decreases, and so
the
If you
height
want to
the
take
height
decreases
reference,
basically would increase or
when you
like
have a formula,
be
then
like
equation will also decrease.
back
yes,
to zero or
yes.
one.
So you
Yeah.
can simply know that there is only one factor that is actually changing.
Height.
Yes, because in this concept, rho, g, both quantities are constant, right? Only depth or
Yeah.
height or distance, whatever we are using for h. Normally, we use the term depth for the liquid. So only this quantity is variable throughout the experiment. So when your depth decrease, so pressure will automatically decrease because density and the gravitational strength remains constant, right?
Mm-hmm.
So let's suppose at this level, so you easily observe that your depth is actually decreased. So you can just simply write in the terms of these quantities, pressure decreases the depth of the liquid, and density and G remains constant. And the questions like this, or if you are going to write the answer with reference of the formula, so if you want to write the reference of the formula in your answer, so you may also include the reference, because in marking scheme they also used to write that formula, because that will also give you the clear concept, right? So greater depth, greater pressure, less depth, less pressure, right?
Yeah.
Okay. Okay, this is related to brake cylinder. So just skip this question. Now again the same question you can see after one question again we are having the same state what is meant by term pressure, that is simple, and explain in terms of molecule why the pressure of the air inside the cane decreases as it is used. So they are talking about the
Pressure,
spray like the room spray or the deodorant or the spray bottles. So they are asking in terms of molecule why the pressure of the molecules.
pressure is the force acting per unit area.
Hmm.
Is that correct?
Okay, but you need to explain in terms of molecules also.
No, I'm answering AI.
Okay, yes,
This one.
that is where is
Yeah.
yes. Pressure is equals to force acting per unit area. That was right.
Okay. Where's the pressure?
Because question is for 3 mark this time. So what are the
But
factor?
sir, for constant temperature,
Hmm.
pressure and volume are inversely proportional.
Yes.
Would it not be increasing? Because the volume inside decreases when the air comes out.
Yeah,
Okay. So basically when air comes out, so volume is actually decreasing. So pressure will be greater or the less one.
increasing. It's supposed to increase.
Yeah, but the
It's like
question
that.
is the opposite. Like,
Okay. So basically they are asking
No,
in
no. If temperature remains constant, then volume and pressure are inversely proportional.
okay, so you need to explain in the terms like that. When we just press the button and the air inside the cane is coming out or the spray inside the cane is coming out. So now you can see initially the number of molecules are greater, right? And when we spray on the keyboard, so now we are having less
I'm
molecule as
there.
compared to the previous one. Yes, clear? So the very first thing is
Can you
now
write down the definition of pressure?
that is simple. You can write it as
So you were lagging like a couple of seconds ago.
Oh, okay. Let me just-
okay.
Oh, it's a force acting.
Yes, so this is the definition. Now we are talking about the air inside the can. So initially we are having a complete like the new one spray, and we are having maximum number of molecule inside, right? And when we just press the nozzle of the cane, so you know that air now is coming out from the cane, right? So initially we are having greater number of molecules, and after the air molecules are coming out, so the number of molecules will be less in the cane, right? So we start or we take the reference like this, okay, with the reference of number of molecules, okay. So we can say that when we start to use the cane, so there will be less air molecule, less air or less air molecules inside the cane, And the next one is, so we you know that now we are having less number of molecules, right? So it means we are
Yeah.
having more empty space, right?
Mm-hmm.
Space inside. So now you know that when there is a free space for the air molecules, so air molecules are always free to move, right? So now air molecules further move away from each other, right?
Yeah.
Molecules.
So
Yes.
so is pressure directly proportional to volume here?
Actually, this is inversely like this because now volume is increasing, because initially we just fill that gas with high
Oh,
pressure,
I understand.
right? Just like the tire, because when your tire bursts, so actually your air molecules is coming out from the tire, so it means that your volume is decreasing and pressure from the outside is increasing. And when you are filling the
Alright.
air molecules inside the tire, so basically there are greater number of molecules, right? So now
Alright.
we are having less air, sorry, we are having more empty space inside, and the air molecules starts to move away from each other, because you know that initially we are having a spray and that air molecules are moving very far away because pressure is greater. And after some time, when we use that cane or when we use that spray, so that air molecule will not move very far away as compared to the original or the new condition of the cane or the spray, right? So that will
Yeah.
increase the volume.
Oh.
And one more thing that you may write in this answer, that there will be a less collision as compared to the previous one, right? Because molecules or the number of molecules are greater initially, so they will collide with the wall more frequently. Now they are colliding less frequently, right?
Then doesn't that mean that volume is equal to pressure, like directly,
Because now
if you
we
say
are,
that point?
no, basically now number of molecules are less, right? Because they have now greater space as compared to initial condition. Because when there are greater number of molecules, so they are at very low distance, right? So they quickly try to push each another. Now they have free space, so they can easily move in any direction freely, right? So they will not collide with that frequent as compared to the original condition, right?
Okay.
Less frequently with the wall. And the next thing is, so now we know that when the collision is less, so automatically your force on the wall decrease, plus your pressure will also decrease, right?
Yeah.
Decreasing the force on the wall. So this is the concept, right? Now you got different points and different idea to write the question, answer of the question like this. So in this way, you can easily explain the concept, right?